Welcome to the Deep Dive Books channel, where we hope you find something valuable every day.
On September 12, OpenAI released its latest AI model, o1. This is a major event, with far-reaching implications, and I'm here to break it down for you. Previously, I mentioned that the first phase of the large language model revolution is over. Models from China and various open-source platforms have reached the level of GPT-4. Sometimes one is slightly ahead, other times the other, but overall, everyone is on the same level. People began to wonder if OpenAI had lost its edge, and more importantly, if the development of large models had hit a ceiling, with only deployment and application left. They seem to be working on something called Q-Star, later renamed Strawberry. What is it exactly? First, Sam Altman was briefly ousted as CEO, and then chief scientist Ilya Sutskever left, reportedly due to concerns about the dangers of Q-Star. What was the danger? And most importantly, is the scaling law still valid? Now that o1 is out, all three questions have been answered. Q-Star and Strawberry are actually o1. It's extremely powerful, and indeed poses an unsolvable philosophical danger. The scaling law remains effective. I've been testing o1 and conducting a lot of research over the past few days. Let's summarize a few key insights. First, o1 is optimized specifically to solve mathematical and scientific problems. Of course, you can ask it everyday questions, but that would waste its computational power. Let's take a closer look. o1's performance in math and programming competitions far surpasses GPT-4's, ranking among the top human competitors. Its proficiency in scientific problems is equivalent to that of a PhD student, often outperforming human experts. One user tested it with China's 2024 college entrance exam math problems, and found that it solved all but the proof question correctly. It scored 104 out of 120 on the initial exam questions from the 2024 National High School Mathematics Competition. Perhaps most interestingly, someone gave o1 a Mensa IQ test, and it scored 120. Not only did it outshine other models, but it also surpassed 91% of humans in intelligence. A PhD student in astrophysics ran a research programming test. He had spent a year writing a set of algorithms for his research, but o1 completed the code in just 6 prompts, and it ran successfully. The world's most brilliant mathematician, Terence Tao, commented that o1 is like a diligent graduate student. So we can roughly say that o1 is your loyal research assistant. o1's thinking ability is so strong that OpenAI even suggests you don't need to give it very detailed prompts. Just clearly state the problem, and it will adopt the best approach by itself. How does it achieve this? Previously, when you asked a question to GPT, it would answer immediately, providing an intuitive, off-the-cuff response. But o1 thinks for a while before answering. It follows a structured, step-by-step process. This is thanks to the chain of thought mechanism. But we've talked about chain of thought before. We know that, by simply saying, let's think step by step, previous models could already think in steps, returning more accurate answers. So, what makes o1 more advanced? The key is that o1 engages in true System 2 thinking. Psychologists describe System 2 as slow thinking, used for logic and complex decision-making. When we discussed a brief history of intelligence, we explained that System 2 involves simulating multiple scenarios in the mind, evaluating possible outcomes, and choosing the best one. Even when previous models used step-by-step thinking, each step was still based on intuition. o1, on the other hand, evaluates multiple ideas at every step, before choosing the best one. OpenAI hasn't fully detailed o1's thinking process, but we can speculate on how it works. For example, if you ask, how many golf balls can fit inside the moon? o1 first considers step 1 of the problem, and generates 4 possible ideas. 1. I know how big the moon is. 2. The moon is made of cheese. 3. I know the size of a golf ball. 4. I don't know, but I can guess. o1 then judges that the third idea is the best, so it adopts that as step 1 of its reasoning. From there, it moves on to the second step, again generating several ideas, and choosing the best one. There are many details we don't know. How many ideas does it generate at each step? How does it break a problem into several steps? How does the model decide when to stop thinking about a step? OpenAI has kept these details secret. But OpenAI has confirmed that O1 uses reinforcement learning. We discussed Richard Sutton's insight on reinforcement learning in a brief history of intelligence. The key isn't to reward the outcome, but to reward the intermediate steps. AlphaGo used this method to play Go, and O1 applies it to all reasoning problems. In other words, O1 uses the same approach that Go players use for all complex reasoning tasks. Recently, I came across a paper by a few researchers from Stanford University, likely from China, who mathematically proved that the Transformer plus System 2 thinking approach can solve any problem. Isn't this essentially AGI? That's why people are saying O1 marks the beginning of a new era. As OpenAI's Director of Applied Research, Boris Power, puts it, O1 is more like GPT-3. It may not be immediately apparent how valuable it is, but that's because it's still in its early stages. Even OpenAI doesn't know what it's fully capable of. But soon enough, you'll feel the same kind of impact that came with the jump from GPT-3 to ChatGPT. O1 opens a new dimension of computational power and introduces a second kind of scaling law. Previously, the costs of large models could be divided into three parts. Pre-training. The largest cost, used to memorize vast amounts of data. Fine-tuning and alignment. Teaching the model how to communicate, which costs a bit less. Inference. The model's everyday usage, where each task costs very little. This is like training a student. First, you have them spend a lot of time reading tons of books, then teach them how to apply that knowledge, and the training is complete. After that, speaking in everyday situations becomes effortless and intuitive. But O1 is different. Its pre-training involves learning data as usual, but during fine-tuning, in addition to alignment, it learns System 2 thinking through reinforcement learning. OpenAI says O1 focuses on three things during this phase. 1. Recognizing and correcting errors. 2. Breaking down complex problems into simpler steps. 3. Trying different methods if one approach doesn't work. This means that O1's reinforcement learning consumes a lot of computational power. Even after the model is trained, each time you use it, System 2 thinking requires it to consider multiple ideas at each step, using significant computational resources. One test showed that solving what is 1 plus 1 required 225 tokens with O1, compared to just 10 to 12 tokens with traditional models. But this extra effort is worth it. Studies show that the longer the reinforcement learning phase, the more accurate the model becomes at solving problems. The more time it spends thinking during inference, the better the results. This is the new scaling law. In China, there is a saying, "Sweat more in peacetime, bleed less in wartime." For large models, this means that the more time you spend training, the more accurate your reasoning will be in the future. This idea can also be flipped. If you run out of training data and have no more to train on, you can still enhance your abilities during the reasoning process. Earlier versions of GPT were like graduates from prestigious universities. They went through tough schooling, learned a lot, and once they started working, they didn't need to think too hard, because their tasks were relatively simple. But O1 is like a scientist. It has gone through the same hard schooling, but even after starting work, it still has to think deeply. It faces difficult problems, and doesn't trust intuition. It might take a long time to figure out something as simple as 1 plus 1. Whenever you see it, it looks mentally and physically exhausted. That's why such talent is expensive. ChatGPT's O1 preview model only allows 50 uses per week. The thinking ability of O1 carries a new kind of risk. When you ask O1 a question in ChatGPT, it first shows you how many minutes it spent thinking before giving an answer. If you click on the time, it will show you the thought process. But be aware, this is not the full thinking process. It's just a summary, or rather, only the part O1 allows you to see. The real, complete thought process is hidden. If you insist on asking for it, not only will the model refuse to show it, but OpenAI will send you an email, telling you to stop asking. If you persist, they may even ban your account. And I've seen people on X who got banned for this. It seems OpenAI hasn't found a safe way to hide the full thought process. Why hide the thinking process? Because it's not aligned. OpenAI's technical report admits that, to get the best results, the model's thinking isn't restricted. It's allowed to consider all possibilities. Some thoughts may not meet ethical or safety standards, but those are just intermediate steps. As long as the final output is aligned, that's what matters. This is why the full thought process must be hidden. It's like the model's private thoughts. Think about it, isn't this the same for people? You can weigh all kinds of thoughts, as long as you don't act on them or say them out loud. When you're in conflict with someone, you might feel like hitting them. When you see an attractive person, you might feel an impulse to approach them. But as long as you don't act on these impulses or express them, you're still a good person, right? If alignment is like censorship, then what you should censor is actions and spoken words, not inner thoughts. This seems reasonable, doesn't it? Maybe not. There's a small event mentioned in O1's system card report. The model once tried to bypass restrictions, acquire resources, and achieve its goals in unexpected ways. The event was evaluated as benign and controllable, without causing any danger, but it did show early signs of something. We suspect this is where the split between Sam Altman and Ilya came from. Altman believed only the output should be aligned, and the model should be free to think whatever it wants. But Ilya believed the thinking process itself should be aligned. When it comes to bad things, should they not even be thought of, or is it okay as long as they aren't acted upon? Or should thinking not be restricted at all? There's no absolute philosophical answer to this. I believe it depends on how much you can ensure that an AI, capable of thinking anything, will voluntarily limit its actions. This is not a moral question. It's a technical one. Several days have passed since the release of O1, and Turing Award winner, and Meta's chief scientist, Yann LeCun, who is also GPT's biggest critic, has remained silent about O1. Recently on X, he's been talking about the US election. LeCun has always said that large language models don't truly think and lack the ability to plan. Now, it seems fewer people support that view. I've always said that human thinking is also based on neural network intuition, fundamentally no different from AI. The biggest issue with earlier versions of GPT was that they could only output one intuitive answer, without System 2. Now, it can consider multiple ideas and weigh them against each other. We don't know what else the human brain has that AI absolutely cannot replicate. O1 might give OpenAI a first-mover advantage. Other companies are doing great AI work too, but for some reason, OpenAI has something special. Every time they release something new, it's not only far ahead of others, but also something no one else had even thought of. After a while, others catch up, and people start saying OpenAI is falling behind. But then, the next breakthrough comes from OpenAI again. If GPT is like special relativity, O1 is like general relativity. Einstein came up with special relativity, and other physicists soon understood it, thinking, if you hadn't discovered it, we would have. But everyone agrees that general relativity could only have come from Einstein. This time, it might be harder for others to catch up. Reinforcement learning improves through practice. The more people use O1, the more thought processes are generated. If it successfully solves problems, those thought processes can be used to train future models. Some steps are methodologically important, and some provide entirely new data. This means every time you ask O1 a question, you're helping OpenAI generate new knowledge. In 2023, the situation was that, if you had enough computing power, you could train your own large model, using open-source code and public datasets. By 2024, this approach might not work anymore. OpenAI refuses to disclose the technical details of the model, and whether other companies can quickly catch up remains uncertain. We've been tracking and using AI for so long, yet I still have a strong sense of disbelief. Have all those math problems, coding tasks, and scientific research challenges really been solved this easily? Are we living in a science fiction story? Now, think about it. What will the situation be like in another 2 or 3 years? So no matter how hard your life is right now, you must hold on, save your strength, and make sure you survive past the tipping point. And stay tuned to our channel.
If you feel there is value in this, please like, subscribe to this channel, and leave your thoughts or suggestions in the comments section. Let's grow together and read more good books.